So let's work one more problem together. This time let's look at a transformed cosecant graph. So thinking about this as cosecant, remember cosecant is the reciprocal of sine. So 1 over sine of x. So every property that the sine graph would have, this is going to have. So let's look at our function. We can see it's negative. So thinking about a negative sign. My a value in this case, -1, so my amplitude is 1. My b value is the number in front, in this case 1. So my period, 2 pi divided by 1 is 2 pi. I do have a phase shift this time. It's pi over 4, again, because that 1 is factored out. That's why this is pi over 4. If it wasn't, please remember to factor. So phase shift pi over 4. Remember, the inside is opposite, so because it says plus pi over 4, the phase shift is actually to the left. So the phase shift negative pi over 4 left, right there, in between here. Midline, think about that as your vertical shift. In this case, +1, so it's going up 1. Just like we're graphing sine and cosine, we are going to shift this over to pi over 4, which is half of pi over 2 for my new y-axis, and up 1. So this is my new horizontal axis. So again, as you can see, this is where we're graphing our function from. And we're going to graph sine to begin with. So the period in this case is 2 pi, so negative pi over 4. So positive pi over 4. 3 pi over 4 is 1 pi. 2 pi. So 1, right here. So again, think from 0 to 2 pi, we're shifting it back pi. So here is my 2 pi. And I'll come back and erase that so it doesn't mess with my graph in just a moment. So again, 2 pi from here to here. Amplitude is 1. So again, from that midline at 1, we're going to go up 1 here and down 1, which hard to see over the x-axis there. Sine starts at a 0, ends at a 0. The middle is 0. So again, think about this visually, half it right here. A quarter of the way through, again, half, you get a maximum. That's why we love pencils in math. And 3/4 of the way through, you would typically get a minimum. But remember what's special about this one is that a is -1. So what happens to these 2 points because it's negative? Is they flip. So here we're going to get a minimum first and then the maximum. So you can see one curve. Again, repeat the process for this all the way through the graph. Now, once we're finished drawing the sine curve, we're going to turn it into cosecant. So just as we saw in the first video, every time we have a 0. Now again, our zeros aren't on the x-axis. They're the ones that cross that midline because of that vertical shift. So the zeros are the ones that cross the midline. So these locations here are now going to be our asymptotes. So everywhere we have that crossing of the midline, we're going to create a vertical asymptote. It should be halfway through. I got a little off over there. So you can see with the orange popping up now that these are the vertical asymptotes. And just like with the basic cosecant and secant graphs, we're going to come back and actually draw the curves depending on, that's off, sorry, where the maxes and mins are. So when there was a minimum, the curve is going down. Where there was a maximum, the curve is going up. What you see graphed in blue, this is one interval. Notice it takes both pieces to get the whole picture, because now here in this third graph here, it looks like I've repeated. So this is one interval from 0 to 2 pi shifted back pi over 4, and then repeating from there. So that's it for me today, guys. Good luck with graphing transformations. Remember, graph the sine or cosine function like normal, like we've been practicing. I believe in you. And then turn it into your cosecant and secant. Good luck.